Hello everyone, welcome back. My name is Bindu Shrim. I am studying Computer Science and Engineering in Sri Venkateshwara College of Engineering, Bangalore. Today in this video, we are going to discuss about the corrosion. And the table of contents are introduction, causes of corrosion, corrosion reactions, types of corrosions, how to prevent corrosion, and the conclusion. Introduction. Destruction of a metal by chemical or electrochemical reaction with its environment. Physical or mechanical wearing away a metal is not called corrosion, but it is called an erosion. If corrosion and erosion take place together, the destruction of the metal takes place very much faster. Corrosion is an unintentional attack on a material by reaction with a surrounding medium. The corrosion problem should be very seriously considered in all those cases where the structure or the equipment is meant to last many years, say 20 years back. And the definition of the corrosion. Corrosion is the deterioration of materials by chemical interaction with the environment. The term corrosion is sometimes also applied to the degradation of plastics, concrete and wood, but generally refers to metals. And the rusting of iron. In this rusting of iron, both cathodic and anodic reactions takes place. And here are the reaction. If iron is exposed to oxygen or the environmental surroundings due to the oxygen or the atmospheric condition, the iron will become a rust. That is known as the rusting of iron. Then the formation of the green rust. Then the next is causes of corrosion. The chemical combined state of the metal is known as ore. The ore has low energy in its thermodynamical state. The extracted metal has high energy, thermodynamically unstable. Metal converts itself into stable state by reacting with the environment and undergoes the corrosion. The corroded metal is thermodynamically stable. Then here is the pic of the formation of the rust. Then effects or disadvantages of corrosion. The valuable metallic properties like conductivity, malleability, ductility, etc. are lost due to corrosion. Lifespan of the metallic parts of the machineries is reduced. The process of corrosion is very harmful and it is responsible for the enormous wastage of metal in the form of its compound. The failure of the machinery takes place due to loss of useful properties of metals. The approximate estimate of loss of metal due to corrosion is $2 to $2.5 billion per annum all over the world. Then here it is the pic of the rusting. This is also a pic of rusting. Then the types of corrosion. Here there are different types of electrochemical corrosions and they are galvanic corrosion, pitting corrosion, integranal corrosion and the waterline corrosion. First, the galvanic corrosion. This corrosion occurs when different metals are in contact and exposed to corrosive atmosphere. The metal which has higher electrode potential value will form anode and undergoes corrosion. For example, ZnCu galvanic cell, zinc behaves as anode and the corrosion occurs. Copper behaves as the cathode and it is protected. And this is an example. Then pitting corrosion. When corrosion starts on the metal surface at certain spots, they become less open to oxygen with the result that corrosion proceeds faster at those very spots, making deeper and deeper cavities. Pitting corrosion can be explained on the basis of differential aeration. The pit created becomes deeper, its bottom becomes less open to oxygen, which makes it more anodic. The part which has higher oxygen concentration is cathodic. And here is the example on the formation of the pitting corrosion. Then the waterline corrosion. The concentration of oxygen dissolved in water is greater at the surface than deeper down. This causes formation of a concentration cell. Anode is the lower portion and the cathode is at the water level. Due to poor conductivity of water, the ions just below the water level are available for reaction. The metal corrodes just below the water level. Here is the example. This is the second example. And the next, how to prevent corrosion. Protective coatings, cathodic protection, inhibitors, corrosion, environmental modification. These are the prevention of the corrosion. Let us discuss one by one. The first is protective coating. Applying a protective coating on the metal surface forms a barrier that separates the metal from corrosive environment. Common coating materials include paints, enamels, and polymer coatings. Cathodic protection. This method involves making the metal to be protected act as a cathode by supplying it with a direct current or by connecting it to sacrificial anode. The sacrificial anode corrodes instead of the metal to be protected. Inhibitors. Corrosion inhibitors are chemicals that are added to the corrosive environment to reduce the corrosion rate. They work by absorbing onto the metal surface, forming a protective layer that inhibits. Then the corrosion alloying. By adding small amounts of alloying elements to a metal, its corrosion resistance can be significantly improved. For example, stainless steel contains chromium, which forms a passive oxide layer that protects the underlying metal. Then the next is environmental modification. Modifying the environment surrounding the metal can help control corrosion. This includes controlling humidity, temperature, pH levels, or removing corrosive gases or contaminants. Then the last part is conclusion. Corrosion control is essential to prevent the deterioration of metals and alloys. Various techniques such as protective coatings, cathodic protection, inhibitors, alloying, environment modification, and design considerations are employed to control corrosion. The selection of the appropriate method depends on the factors such as the type of metal, the corrosive environment, and the desired level of the protection. By implementing effective corrosion control measures, the lifespan and the performance of a metals can be significantly enhanced. Thank you. Thanks for watching the video.